and be like, well, which operating system are you on? Because you're going to have to include like 14 different libraries to do that. And you're like, to hell with it, I'll just include Qt. And then you're like, well, why is my executable 200 megabytes? So yeah, C++ is a much slower language to develop in than Java. And you can legitimately make games in Java, like Minecraft, right? Like that was in Java, or is in Java. I don't even know what Minecraft is in now, but since they ported it to just about everything, it's owned by Microsoft. But you can make stuff in Java for games, and it works pretty well for small projects. Like there are so many games like Towns and the rest in Java, which are fun, but the devs. I would get started if you're wanting to do C++ game dev. Unreal 4 is a pretty good place to do that because there's a mix of C++ and they have a lot of stuff already done for you. So if you want to be cross-platform, that's pretty much built in. They have all the nice wrappers for files and threads and crazy stuff like that, and you're not going to spend 2 million years trying to figure out exactly like what library you need to include to do just something. There's most of it's already there. So for example, I wanted to make threads and I kind of just wrapped my own thread utils stuff, but basically if you want to make a thread, they have like they've got critical sections all nicely set up for you that are cross-platform. They've got like F platform process and a whole bunch of utility functions to help you out. Things like that where you can get all sorts of crazy operating system specific stuff without having to do a whole hell of a lot. So I would start, if you're going to do C++, I would start within an engine, since you obviously already know how to program. Saying like, oh, well, you should start with a different language and learn your fundamentals. But, well, you've already got your fundamentals. The big thing that's going to be a big pain in the butt coming from Java is, of course, memory management. And something like Unreal, where they kind of manage the memory for you. It works a little bit like Java with its reference counting and smart pointers. Might give you an easier transition into dealing with all that crap yourself. Though you probably already know what you're doing with that. So I'd start within something like Unreal, and it'll help you out with profiling tools, debugging stuff. There'll be a lot more references, and kind of what I've found is if you don't have the scaffolding upon which to kind of apply your knowledge, you can get paralyzed with a big language like C++, not knowing where to start. So it can help guide you with like, this is kind of how you should do things, and you can see if you like it or not. Though there's going to be a lot of stuff like, God, Unreal's huge in terms of like actually getting started. You kind of have to know tons of stuff to get the project set up. So it could be a real pain in the ass. But that's C++ dev. Got overwhelmed with all the generated bits. At the same time, you're surrounded by well-written code. Ha! Well-written code is, of course, quote-unquote well-written. Yeah, the code generation stuff is just nasty. Like that's kind of how large C++ projects are structured. Is you generate like all the make files and all the crazy stuff. Yeah, Java is basically like I can boot up some of the Java utils that I've got. Let me just make sure there's nothing crazy in here. course now Eclipse doesn't want to open up because Perforce is being a real pain in the ass. Unable to connect. Feature. Yeah, but like, you know, with Java, you've got all your stuff nicely organized. You don't have to do a whole bunch of crazy stuff. Just like, okay, you know, I want to, you know, mess around with like an XMPP client. You know, you can just go make stuff and just make it work. And it's real simple. You got your nice organization with your package structure. You've got your build process that sets up all the dependencies and all that stuff. So, yeah, and also when you're typing stuff out, you know, IntelliSense is there to just help you get everything working. And IntelliSense in C++ land just like never frickin' works. So, you know, it's basically like good luck, buddy. So it's kind of rough moving from, you know, from Java to something like C++, because it's just a huge pain in the ass. So you're trying to learn it. You got a simple game idea. Well, I would just say if you've got a game idea, you don't have to write your game in C++ to start with. You can always write your game in something else, and then, I mean, most people do prototype games outside of C++ land because it just takes too freaking long to get anything working. So the question is, why are we resetting these components? We should not be. Like, our components should be reset properly. Yeah, some people just... Like, that's what I found with Java development, was I was just able to do stuff. Just once you had, like, critical mass in your project of Java code, you're able to do things like super quick. Like one of the things that when I was working at Amazon, we needed our play from home login site for our beta set up, and so we had to make this website from scratch and get it so Amazon employees could log in from home to play our game, which, as you can imagine, the InfoSec guys and AppSec guys were like, holy crap, logging in from, you know, public internet for a beta game, like, you better lock this down properly. So we had to go through, like, you know, crazy security reviews and get all this stuff done, and we had like one day to do it. And we were just able to do it because we had all our stuff set up. So thank you for following BuzzLink. And we're just like, boom, you know, okay, new server, port, you know, whatever, SSL's done. Just set it up. Okay, now we can get our page working with FreeMarker on our servlet here, and here's the login, and we just throw it all together, got it out there, got it live, got it public to the world within one working day. And, you know, doing that in C++ pretty much would have been a gigantic pain in the ass, unless we had everything done, but it would take so much longer to get to that point where you have that critical mass. Basically, this game is Dashkin. I'll link the website here. Basically, it's a high-speed platformer game. It's gonna be 2D, and we're gonna see if we have 3D components to it, like 3D backgrounds and the rest. And I'm working with Adam Phillips, who you may remember from the Bitey of Brackenwood series. 901. You're saying? Alright, so what is our local rotator? Is zeros. Our origin is zeros. Why is our... This is interesting that our origin is not equal to our local rotator here, because Maybe this is just something we have to do where we're dealing with floating point math, so we have to just do a few things. Concept art is sweet. Well, yeah, that's because Adam is a master at what he does. If you don't know Adam from Bitey of Brackenwood, he's an assistant director on Bob's Burgers. You may know that show. So he's splitting his time working for Bob's Burgers and working on this game. And he is the guy who owns like the whole story and everything. Alright, let's just see. Greater than tiny float. Yeah, dude is super busy. 2 files for one class. I never what goes in the header and how much. Yeah. That's another thing that's a gigantic pain in the ass with C++ is, your header files declare the stuff that's in the function, in the, the CPP file, and figuring all that stuff out. And then something like, Unreal 4 comes along and it's not even that simple anymore. Like, when Unreal 4 is compiling CPP files, it's actually like throwing all the CPP files together and compiling them. So even like static, what you would expect to be, file-specific variables are no longer file-specific variables. They're kind of undefined where they're actually going to get compiled and stuff like that. In Java, you'd just be like, okay, I went and made this object. I can now reference it from anywhere. And that's not the case with C++. Order matters. And that's another nice thing about having Unreal there. Is kind of you can follow the structure of what they've got set up. And getting proper header structure and everything else is just kind of something you gotta bang your head against the wall until you know what you're doing. Alright, so that looks like that has fixed our initial overlap test issues. I'm not seeing any more craziness. Yeah, we're setting back to where we should, which is exactly what we should be doing. I'm gonna zoom back in real quick. So we're probably fixing our child transforms on that one. We'll just double check. Yeah, but if you're going for C++ game dev, the other thing I would highly recommend is that you get somebody to work with who usually just a little bit better than you or more familiar at C++. And that way, because if you're working with somebody who's like a super expert, it's difficult to learn from them because they already know everything, and it can be difficult because they're like 3 steps ahead all the time on like, oh, you should structure your class like this, and you're like, why? And they're like, well, because that's just what you do. And if you get somebody who's like kind of on the same level but a little bit ahead, they can help you out on stuff, but they're not like 4 steps ahead of you in terms of what they're doing. They're more relatable. Alright, so that's looking proper. Let's throw some fat sacks back in there and see what we can do with them. Let's just throw 1 in there to start with. And a good place to find those people is... He just frickin' left, didn't he? Come back here, you little bastard. I need a I need to make them a lot slower. Well, I can do that right here, can't I? So these fat sack proxies are using the fat sack slow movement, so let's boot that open. And I'm going to change their walk speed, his movement velocity to like 100, and his jump velocity to like 100 again. So we're going to make him super slow. What the fuck is that? It's a duck? It's a fat sack. Fat sack's a little character in the game. Yeah. If you have not seen any of that, let me just pull that up. Fat Sack is just one of these little critters, and he's one of the background little dudes that's going to be in the game, and I'm just using him to test out basic movement stuff. So he's not a duck, he's a little sack of digestive juices that runs around and digs in the dirt. But we're just using him to test a few things. So what we're really looking for here is getting stuck. We've got some complex logic for these characters. So just want to make sure that we're not getting completely stuck inside of them. And it doesn't look like we are getting stuck. And we may have fixed some of our problems. Which is good, that's what we were looking for. And the flashing little bars there, basically, on halfway through this guy's animation, I'd have to pull up Toon Boom, but basically, halfway through this guy's animation, what happens is he's got a hitbox for his character that looks like this, and halfway through his animation, it clips off only like if this is the middle of the character, halfway through his animation, it clips off one entire side, and that way I can, and when I flip the character, like when he's facing right, you know, his butt will be sticking out that way. When he's facing left, or when he's facing left, his butt will stick out this way, and he's facing right, his butt will stick out the other way. So I can go to a wall and like go back and forth and make sure I don't get stuck in the wall and stuff like that. And then I need to do that for other characters, so we've got this kind of complex geometry situation going on. Alright, so now we should have like 4 of these guys, and let's go make sure we can actually not get stuck. Looks like those guys are stuck. So it's the AI getting stuck together. The child object is still colliding with the world after yaw transform. So does it have to do with changing our animations, perhaps? Well, it looks like we probably have to... Yeah, this is going to be with changing animations. Let's actually try that real quick. Let's just completely disable the animation switching for the fat sacks, because we're not doing that for ourselves, and there's probably something busted with our animations. So we're just gonna go to our really crappy FatSec AI. Let's just throw a pool in here, like change anims, and we'll set it to balls. And the FatSec AI here is just awful. It's just trash code. So we're not gonna try to pretty it up. It's just if change anims, then change anims. Nobody cares about any of this piece of junk. Because it's not what we want. This is not how we want to write our AI. We do not want to write our agent AI in C++. That's an awful idea. We've got blueprints. We should set it up so we can do it that way. That's usually how you structure C++ projects for game development. Is you'll have a main language which kind of has all the nuts and bolts and all your tools. So you'd have things like, can I move to this location, or move this object over here, or face me towards something else, or make an object. You put all those in C++ land where they need to be super quick, and then you put all your actual code for your agent AI and your levels and everything, and that should go off into something much easier to deal with. Like in a lot of games, like you'd see 5 years ago, it would be some sort of scripting language like Lua or something else, and now it's kind of moving towards these visual scripting editors like Blueprints, and in CryEngine you've got Flowgraph and all that. And that's so like designers can more easily work with it. But if you're an engineer and you're making your own game, I would highly recommend hooking up like Lua or something else, because it's real easy to work in. It kind of lets you have a nice little area to have awful code. Alright, so these guys are no longer changing animations. And we want to see if they get stuck inside of each other like they were earlier. And it looks like they do. So let's just snag this log file and see what it's got for us. We're already stuck when trying to fix components. So we were stuck to begin with, is what it's looking like. Yeah, we are already stuck when trying to change directions. So it doesn't have to do it with the animation, it looks like. So we're already stuck when trying to fix components. So what is this? This is Dashkin Fatsack movement. Yeah, debugging these physics things can be a real pain in the ass because you try and figure out exactly what's going on, and it's not always clear exactly. So this is flipped around. It's negative 180. So we were already colliding, and then we're setting it, and we're still colliding again. Where are we overlapping? It's not our can play animations. So, I guess we're already stuck in an object. Somehow we got moved into one? How did that happen? Oh wow, okay, so we're already stuck. And so what is this? This is dash, that's like movement on the ground, heading to the right. What are we overlapping? So we're overlapping another actor. Damn, okay, so something else is going on here that's not good. So one of our movement states is actually making it so we're colliding. So the question is exactly what is that, and can I isolate it so I can actually have a good test case for it? So we're just gonna reduce the number of fat sacks in the scene. So we actually just immediately get stuck in this guy. He is just completely stuck. Okay, so if he's totally stuck, let's just make sure we didn't spawn him into the frickin' ground or something. Nice. So what we'd like to do is we want to figure out why this thing is stuck. It's going to be stuck for a specific reason. That reason appears to be when we approach from the left side to this guy who is on the right. Oh, stop it. Alright, so at least it looks like we're able to reproduce this with just one other character moving. So we're gonna have to see what exactly this is. God, I'm trying to think. I'm not exactly sure. Like basically when we approach this guy from the left, all of a sudden we get stuck inside of it, which is not ideal. That's not what we want to see. Because our collision, basically, as soon as that happens, and we're stuck. For some reason, we get stuck. We don't get stuck if we're on top of each other, but as soon as this animation thing plays, basically the animation is putting us inside of it, is what it looks like. So there's something wrong with their animated physics, is what it kind of looks like. Yeah, and we're still having all these drops from to our server, our Perforce server for some reason, but looks like I might be having the same thing with bitrate to Twitch, where these Perforce drops are coinciding with these drops with just internet connectivity in general. Maybe I should go complain to my ISP, see what the hell's going on there, because we're just having so many drops of connection drops that it's got to be something. It's got to be something outside of my control. It's crazy. So I'm gonna actually check if stuck before we took our movement, because That should never happen. Oh boy, stop! Not do that. And then I want to take another look at our callback here. We got this is overlapping with world callback. Our animation is telling us that our new state will collide with the world. Maybe that I'm not rebuilding the physics when I should be. Something like that as well. Yeah, so we got stuck before we actually moved. And checking the logs, it says we're stuck, and that's just how it is. So the question would be, why are we stuck? Well, maybe we can do something about it. Where are we calling this? Is overlapping with world. It's in paper sprite component, isn't it? It's not paper sprite, it's paper book. So let's see, if we just said always true, don't change our physics, then we might be able to just have this thing just have it return true here. We might be able to force it. I'm just trying to disable some functionality so I can try to lock down exactly what is getting us stuck. And it definitely looks like it's our turning code that's getting us stuck. It's this is what I'm looking at right here. So I do show collision. I've disabled the animation stuff, so you can definitely see now that we're not having that bar up here. When we get up to him and then we turn around, we're getting ourselves stuck inside of him. So, it has to do with turning around. Alright, so it's like set direction. So maybe we need to call refresh physics on it. Is that something we need to do? Let's see, what exactly does the refresh physics do? I think it's paper physics object physics component.cvp refresh physics marks the render dynamic data dirty and recreates the physics state. So maybe we need to do that. If we change. So maybe that's just something we need to do for every component, is just set it up. Because I did test the overlaps properly before to make sure that they actually did work if we flip them around. But it looks like it's just not taking. Maybe we don't even need another creature to test this out. Maybe we could just do it against a wall. No. So we should be able to reproduce this without anything insane, just by changing our set wanted direction. We're setting our wanted direction based on our velocity, aren't we? So what we should do is actually set our velocity real low. That way we'll go over to the terrain. It's just fat sack movement data. set it to something much lower. Yeah, and that definitely is just not working as it should. So it's not a thing with our dynamic objects. It's just it's an issue with just our flipping and our direction vector. So what we're going to do is we're going to disable a few more things. We're just going to remove that. And when we set our direction, we are setting our actor rotation, which is proper. So it's basically like we're getting our just gonna see what this does when we actually do it. Well, at least I've got the case narrowed down to us and a wall. That's something I can actually test real quick. Alright, so I'm against the wall and I hit the other direction. What happens? We set our actor transform and our rotation changes so that we have flipped about the z-axis. Okay, and for every component, we're going to grab the local rotator. The local rotator says nothing, so we're set properly, and we're going to then see if we overlap with the world. And we do, so we're going to set it to our flip, and we're going to check, and it says after flipping, we don't collide. So we're fine. But then we're still stuck. Wait, what? Well, obviously what I also need to do here is just remove the debug drawing for some of these things, because we don't want the debug drawing for... It's got to be inside the... We don't want the debug drawing if it's not a physics object. So what can we do to remove some of those hitboxes? I could just remove the hitbox from the thing entirely. Because I don't want to see that in show collision. I just want to see the actual collision object that we have currently, not the ridiculous stuff. So if we go into FATSAC, maybe we can just remove that from the idle one. Would you put a static variable in the header? So a good example might be I've just got some random global variables here. So in my header, I've got things that are like static const, and then like G camera follow speed. And in the CPP, it looks like this. So it's inside of a class, so it's Dashkin global utils, and then this static const float. And then inside of the CPP, you actually have to put the namespace in front of the variable name. So it's like const float, Dashkin global utils, namespace, then the actual object, and then you define it. So if you're going to do static members inside of a class, then you need to put the namespace in front of the variable name. It's just like you do with functions, where you put the namespace in front of the function. Kind of like here's the constructor for the object. So it's just, you do the same thing with variables when they're static variables. And yeah, you can't define anything inside of the CPP. You're just declaring it. You're like, hey, this thing exists. So I think that's what you were asking. So hopefully that helps you out a little bit. Because that's what you do in Java, right? Just public static final something, and just define it right inline. It's real convenient. Where were we? We were going to remove these things from his idle. So his S idle. So we got keyframes, we got collision objects. This is the body physics object. What I'd like to do is just, if I can remove this. Alright, so it does look like it took. So we're gonna see how this looks in show collision. Yeah, so we're not seeing two collision boxes now. Good. And we turn around and alright. So it looks like we may not be out of the woods with this. Static variable declared and given a value in the header. So basically the idea with the headers is that the headers get included in other files. So if you declared a static variable in the header and also defined it inside of the header, then that variable will, if anybody else includes that header, then that variable is going to be defined twice, and the compiler is gonna bitch at you, tell you can't do that. So yeah, you don't define anything inside of the header because that's where the actual information lives about the object. You just want to basically give it the roadmap of hey, all these things should exist, and then you actually define them in the CPPs, and the CPPs only get compiled once. So if you define something inside of a header, you could only include that header once, otherwise shit explodes. So yeah, I would not ever define anything inside of a header if it's an actual variable. Yeah, it's you could think of it like that, but it gets even more complicated than that. But yeah, that's at least a place to start with thinking about headers. Alright, so we need a fat sack dude on here. Where'd he go? He ran off? There he is. Well, now it looks like we're not getting stuck. See, is he ever going to come out of the wall? We're not getting stuck there, so it has something to do with when we were fixing our components is what it looks like. Well, let's see. So what the hell are we even doing when we're fixing our components? Well, we are going over all of our components. We are checking if there's a value to the local rotator. Local rotator is the relative transformation. And if there is a relative transformation, then we are attempting to transform it to the origin. We're basically flipping it to where it should be. It should always be at 0. And if it collides, then we flip it back to what it should